SECTIO and 2 Define Phase. Chapter 2.3 Critical to Quality CTQ Development. Critical to Quality, or CTQ, refers to the key measurable characteristics of a product or process that must be met to satisfy customer needs and expectations in the define phase of Six Sigma. CTQ development helps translate the voice of the customer into clear, specific, and measurable requirements that guide process improvement efforts. By identifying what is truly critical from the customer's perspective, organizations can focus their resources on improving the factors that directly impact quality, performance, and customer satisfaction, ensuring that improvement initiatives deliver meaningful and measurable business results. Critical to quality CTQ characteristics are measurable performance requirements that a product, service, or process must achieve in order to meet customer needs and expectations. In simple terms, CTQs convert the voice of the customer VOC into clear numbers, limits, and specifications, removing ambiguity from design and improvement efforts. Without well-defined CTQs, requirements remain vague and open to interpretation, often leading to inconsistent results and customer dissatisfaction. This chapter explains how CTQs are developed and structured through four key elements: CTQ flowdown, which translates high-level customer needs into specific process-level requirements; CTQ trees and decomposition, which break broad needs into measurable and controllable factors; prioritization matrices, which help identify the most critical CTQs based on customer impact and business importance; and CTQ specification development, where precise targets, tolerances, and performance limits are defined to guide effective design and improvement decisions. CTQ flowdown is the structured process of breaking down customer needs into clear, measurable elements step by step so that they can be designed, controlled, and improved effectively. It ensures a logical translation from what the customer wants to clearly defined needs, then into CTQs, followed by design specifications, component specifications, and finally process specifications. Flowdown is essential because the voice of the customer is often expressed at a high level or emotional level and cannot be used directly for design or improvement. For example, when a customer says, "The loan process should be fast," this statement is subjective and vague. Through CTQ flowdown, this expectation is converted into measurable requirements such as approval turnaround time, document verification time, or system response time, making the requirement actionable and design-ready. The CTQ flowdown for a loan approval process shows how a vague customer expectation is converted into clear, measurable, and actionable requirements. When the voice of the customer states fast loan approval, the underlying customer need is to reduce the total approval time. This need is translated into a primary CTQ by defining a measurable target, such as keeping the approval turnaround time within 2 hours. To achieve this, the primary CTQ is further broken down into secondary CTQs, including limiting document upload time to 5 minutes, system verification time to 20 minutes, and underwriting decision time to 30 minutes. These measurable CTQs then drive specific design requirements such as the use of automated KYC APIS, rule-based eligibility engines, priority routing, and auto-verification workflows. This structured breakdown is the essence of CTQ flowdown, where a single vague requirement is systematically transformed into multiple measurable design and process elements that can be implemented and controlled. Another example of CTQ flowdown can be seen in improving mobile app login speed. When the voice of the customer says, "App should open quickly," the underlying customer need is a fast load time. This is translated into a primary CTQ, specifying that the app should open in less than 2 seconds. The primary CTQ is further broken down into secondary CTQs, such as API response time under 100 milliseconds, data fetch time under 300 milliseconds, and screen render time under 1 second. These measurable requirements then guide detailed design decisions, including database optimization, caching strategies, and reducing image sizes. This process illustrates CTQ flowdown, where a high-level customer expectation is systematically converted into actionable and measurable design elements. A CTQ tree is a visual tool that helps systematically convert the voice of the customer VOC into measurable requirements and actionable design specifications. The structure of a CTQ tree begins with the VOC at the top, which is then broken down into specific customer needs. Each customer need is further translated into one or more CTQs, which are measurable and quantifiable requirements. Finally, these CTQs are decomposed into detailed design specifications that guide product or process development. By using CTQ trees, organizations can clearly visualize the hierarchy from high-level customer expectations to precise, implementable design and process elements, ensuring alignment with customer priorities. A CTQ tree visually breaks down the voice of the customer VOC into measurable and actionable requirements. For example, a customer may say, "I want quick and accurate service." This VOC is translated into specific customer needs such as fast service and error-free service. These needs are then converted into measurable CTQs, including average handling time AHT of 4 minutes or less, first contact resolution FCR of 90% or higher, and an error rate of 1% or less. Finally, these CTQs guide the development of detailed design specifications, such as ensuring the CRM single view loads in under 5 seconds, incorporating validation checks, and using standardized scripts for the most common call types. This decomposition ensures that customer expectations are systematically translated into concrete, measurable, and implementable elements. A CTQ tree can help translate patient feedback into measurable and actionable requirements. For instance, when patients say, "Waiting is too long," it's confusing. The VOC is broken down into specific needs. The first need is a short waiting time, which translates into a CTQ of waiting time under 20 minutes and is addressed with a design specification such as a digital token system. The second need is easy navigation, converted into a CTQ of one-step direction clarity, implemented through digital signboards and SMS directions. CTQ trees provide a clear, structured way to decompose broad, high-level feedback into precise, measurable, and implementable design elements. Not all CTQs carry the same level of importance, so it is essential to prioritize them to ensure that designers and process teams focus on the factors that matter most to the customer and the business. A prioritization matrix is used because resources and time are limited, customer expectations vary, and some CTQs have a greater impact on overall satisfaction. The matrix evaluates each CTQ based on key factors such as customer importance 1 to 5, impact on quality 1 to 5, risk if not achieved 1 to 5, and feasibility 1 to 5. A total score is then calculated, often as a weighted sum, which helps rank CTQs and guide decision-making so that critical requirements are addressed first. Prioritization matrix helps determine which CTQs require the most attention during design and development. For a new CRM system, CTQs were evaluated based on customer importance, impact on quality, risk if not achieved, and feasibility. Scores were calculated as follows: information load time less than 5 sec scored 19, error rate less than 1% scored 17, task completion in less than 3 screens scored 16, and auto summary notes scored 13. Based on these scores, the design team should focus first on improving load time, then minimizing errors, and finally optimizing task flow across screens. This structured approach ensures that limited resources are directed toward the requirements that matter most to customers and have the highest impact on system performance. A CTQ prioritization matrix helps focus design and development efforts on what truly matters to customers. For a mobile app, CTQs can be ranked by priority score. App load time under 2 seconds is rated very high, crash rate below 0.1% is high, personalized offers are medium, and dark mode is low. This prioritization ensures the team concentrates on critical features that directly impact user experience and satisfaction, avoiding wasted effort on low-impact features. Once CTQs are identified and prioritized, the next step is to define their specifications. A CTQ specification clearly answers for key questions: how the CTQ will be measured, what the target value is, what the acceptable range or tolerance is, and how a defect is defined. By specifying these details, CTQs are transformed from abstract customer requirements into precise design rules that can guide product or process development, quality control, and performance monitoring, ensuring that customer expectations are consistently met. When defining CTQs, it's important to translate them into clear, actionable specifications that guide design and quality efforts. Each CTQ should have a metric name that identifies what is being measured and a definition that explains it clearly. The target value sets the desired performance level, while upper and lower limits define the acceptable range. It's crucial to specify how the metric is measured, where in the process it is measured, and the frequency of measurement to ensure consistent monitoring. Finally, defect criteria define when the metric falls outside acceptable limits. Together, these elements turn abstract customer requirements into precise, measurable design rules, ensuring that products or processes consistently meet customer expectations. Here's a practical example of a CTQ specification for a mobile app's load time. The metric is load time, defined as the time from when the user taps the app icon to the moment the first usable screen appears. The target is under 2 seconds, with an upper limit of 2.5 seconds. No lower limit is required. Measurement can be done using a stopwatch or automated server logs, and it should be tracked in the server logs. The frequency of measurement is every app release, and a defect is defined as any load time exceeding 2.5 seconds. This specification ensures the CTQ is measurable, actionable, and clearly tied to user experience. For a BPO process, a key CTQ could be accuracy, defined as the percentage of transactions processed error-free. The target is set at 98% or higher, with a lower limit of 97% to define acceptable performance. Measurement is performed through QA sampling on a daily basis. A defect is identified if there is an error in any mandatory field. This specification ensures that accuracy is clearly quantified, monitored regularly, and actionable, helping maintain high-quality service that meets customer expectations. For a hospital outpatient process, a critical CTQ is waiting time with a target of less than 20 minutes. Measurement is done using digital token logs, which track when patients arrive and are called for service. A defect is defined as any waiting time exceeding 20 minutes. This specification provides a clear, measurable standard to ensure timely patient service and improve overall patient experience. When designing a new express claims process, the voice of the customer VOC might include statements like, "I want faster claim settlement," and "why so many follow-ups." These high-level expectations are translated into specific customer needs, such as quick processing and clear communication. From these needs, measurable CTQs are developed: settlement within 6 hours, SMS updates at every stage, and accuracy of 98% or higher. This flow ensures that customer feedback is systematically converted into actionable, measurable requirements that guide process design and improvement. After identifying the CTQs for the new express claims process, the next step is CTQ prioritization. Here, speed is rated highest with a score of 20, accuracy follows with 18, and updates score 15. Based on these priorities, CTQ specifications are defined. Turnaround time target is less than or equal to 6 hours, with a defect defined as any claim taking longer than 6 hours. Accuracy is measured to ensure errors remain below 2%. This structured approach demonstrates how DFSS translates customer expectations into clear, measurable, and actionable design requirements, making the process design transparent and focused on what matters most.